Good evening, ladies and gentlemen. I would like to welcome you on the board of the highway aircraft. We will travel
Well, here we are again in another installment of RV12 Driver. It's been a while since I showed you guys anything cool. I may not have shown you the Smart Glide install and also the warning light and warning button install. And if anyone wants to see those, let me know. I have the footage. I don't think I put together a video about those. But today we're looking at the Starlink Mini. This is a new device that came out, I think in June or July. Let me go around to the back side here. So Starlink is one of those SpaceX, Elon Musk companies, and they've launched a whole ton of low Earth orbit satellites. I think they're about 200 or 300 miles up, and there's hundreds of them. I don't know the exact number, but this guy came out, and there's been videos in the past about the regular Starlink terminal, which is about double the size, not double, but it's like two of these next to each other. It's like more rectangular. And as you can see right here, there's not really enough room. I don't think there's enough room to have one of those. But the Starlink Mini terminal accomplishes a couple things. One is that it's about 1 square foot, so it'll actually fit nicely in the rear window here of the RV12. The second thing it does is that it accepts a wide range of voltage inputs. I think it goes from 12 volts up to 48 volts. I think it's 48 volts, which is great because with the older terminal, I believe the older terminal only supported 24 volts, and so you needed to convert the voltages, and you needed a device to do that, and it was just, you could do it, but it was a mess. So this one, because of the wide voltage inputs, you can wire this directly into your system. So let me go around front. Let me show you how I ran this wire. Let's go over here, take a look. So the wire comes out of, well, let me get in here for you guys. And let's see here, can we go up and zoom out? Yeah. So the wire comes out of the back of the terminal. I have it going behind this this fabric covering here, the bulkhead covering, and it runs against the bulkhead down here and behind this carpet, and it eventually goes into the same hole. You guys won't be able to see this. This is really down in there. I've gotten a light for you guys so you can see. If I zoom in, it goes right down into that same hole where you have these electrical, there, well, you can't really see it, but it goes into the floor. And it's the same route that the electrical wires follow that go from this light through here, down through the floor. It goes under the, follows the same route as everything else, under the floorboards, up here, makes a turn into here, and it goes up and terminates right back here. And if I show you the wiring diagram, this is the RV12IS. It goes into the back of the AV60000 control board back there. And there's not really a good place to hook up extra equipment. We have fuses for stuff, but they're all taken up by EFIS and COM and autopilot and a whole bunch of things. So what I did was I hooked it up directly to the red and the black. The black is the aircraft ground. The red is basically going to the starter solenoid and the backup battery. So this is powered when the master is turned on. So as soon as you flip that master on, you're going to expend an extra 3.5 amps or so to power this guy here. Ideally, he would be tied into the avionics master, which I've left on. Turn that back off. However, to do that, it would require a lot more engineering, and this is a first iteration for me. For the avionics master, well, it's a 10 amp circuit right here. So that goes down to the avionics switch, and then that goes down into some stuff down here. But we would be putting an extra 4 amps, 3.5, 4 amps on that 10 amp breaker for the avionics. I don't really want to be doing that. Last thing I want is to create an overload, blow that circuit breaker, and then I've lost the radio and some other stuff. I'd rather just not deal with that. So by hooking it to this red terminal though, the downside to this is that as the engine is running, we're going to be producing power through here from the generator, through the shunt. So we're going to measure the output of the generator, which is fine. It's going to go through here, through the generator fuse, the green fuse, and then it's going to come up here and it's going to recharge the battery and it's going to power the Starlink terminal. So your battery amperage may show that you're charging your battery, even though you're really not. Those extra couple amps aren't going to the battery, they're actually going to the Starlink terminal. So just keep that in mind. The other thing that I needed to deal with too was how to actually hook up the wire to those terminals. So if we go over here to the workbench, make some room for you guys. All right, so to wire this, the only thing I needed to wire was actually the power, right? So this was a wire that, well, part of the wire that came with Starlink, the Starlink Mini. So one end is a barrel connector. This is typical 12 volt barrel connector, 5.5 millimeter on the outside and 2.0, I think it's 2.0 on the inside. And this is I want to say it's a special cable because it has these rubber rings around it. When you plug it into Starlink, it makes a watertight connection, or I should say water-resistant connection. So this wire gets plugged into Starlink, gets routed through the, under the floorboards, and then it comes out to that power module in the front of the plane. So this is going to go into a fuse holder, which I don't have pictured here. I'll put up a picture from the Auto Parts web store. The fuse holder will hold a 5 amp fuse. In my measurements, it looked like it consumes about 3.5, maybe 4 amps at times of power, so 5 amps is fine. And this is also a 16 gauge wire, so 5 amps can go over this just fine, especially at the short distance there. I also got some blue, and the blue ones because these are the 14 to 16 gauge, and that fuse holder from the Auto Parts store I think was actually 12 gauge wire. So you'll need one of these connectors here. The only special thing about this is that it's for a number 8 ring. The standard, usually the standard for the blue ones are these guys here, which have a larger ring. The aircraft uses a number 6 screw, so this number 8 is fine. If you can find number 6, that's better, but number 8 works fine. Also, one of the issues I was concerned about was the heat. So before I installed this here, I put this out on the taxiway, just outside my hangar, and I powered it for about 15 minutes just to make sure the thing worked. And when you touch this top surface here, this was really, really hot. I got my infrared thermometer and it was measuring 120 degrees. So my concern here was that when you suction cup mount this, you have maybe, my hand is underneath here if you can't see. That's about 2 fingers, maybe an inch at some points here. On the sides, it goes down to maybe 1 finger. So the distance between the plexiglass and the antenna vary, but at 120 degrees, I read that plexiglass can withstand 180 degrees. So I wasn't really sure of any, what the possible heat transfer would be from the antenna to the plexiglass. But during flight testing, I saw that the temperature was elevated on the plexiglass in this area, but it was by 5 or 10 degrees. It wasn't anything crazy. So this kit comes with 2 brackets, an A and a B, and the thickness of them are different sizes because on the Starlink, one side is a little bit thicker than the other side. So what I've done is on the B bracket, I've bent one of the ears up like this. And the idea here is that when we mount this, we're going to take this and screw it into that screw here. Now, most people don't have a speaker and that screw there. At least I don't think we do. But this is going to go right onto that, like that. And then on this side over here, we're going to have the suction cup. Okay, and for the A mount, I've done the same thing. So again, this guy here is going to go right back there like that. So I'll have to drill a hole somewhere over here. So let's see how that goes. So this is our final product here. We got the 2 suction cups, and then we're hard mounted a screw there and a screw back there, just by bending these two brackets. The brackets are they're really snug against the Starlink, and they have a little strip of like felt material inside. So I guess there is potential for the unit to slide out of those brackets, but it's in there pretty good. So I'm sure that's not going to go anywhere. Also, too, the curvature of the plexiglass will prevent it from really moving out, even if it were to slide. These suction cups feel solid. The real test is if you go up to 10,000 feet and see if the suction cups hold, just because of the air pressure change. So that looks good.
So now the big question is okay, I got internet in the aircraft. Now, what can I really do with it? And the answer is pretty much anything. So in the air, you're going to be able to surf the web. You can watch YouTube videos, or your passenger can watch YouTube videos. You can make FaceTime calls. You can make even a standard phone call, as long as your carrier supports Wi-Fi calling, and most of them do these days. You can receive regular phone calls as well. So if your wife or girlfriend is calling to ask you when you're going to be home for dinner, or what time you're going to be landing, so I can meet you at the airport, you're going to be able to do that. And the caller has no idea that the call is being routed over Wi-Fi to your phone. So just make sure it's turned on in your settings. So other things that you can do is you can live stream to YouTube, which is what I did at Sun and Fun. What you're watching here is the actual live stream from my aircraft to YouTube during Sun and Fun as I'm actually landing here. So what you're really looking for is any blockiness that you see, especially when you are in a turn, because the antenna sometimes has a difficult time tracking its own motion and knowing which way to beam the signal to the satellite. But when straight and level flight, which is 95% of your flying, no problem at all. So as far as cost goes, in my case, I had the XM Music and Weather subscription, which I can display the weather on the G3X. I canceled that. That's saving me $45 a month. I get my music through my phone now. I stream using Spotify or Pandora, or one of those free music services. And for weather, I got the weather on my phone. I also have the Frisbee weather, from the ground stations on the G3X. So I'm saving some money, not needing XM anymore. And then the actual Starlink plan is costing me $65 a month. And for that, you get 50 gigs of data. You can also add more blocks of data if you go over that, but 50 gigs is more than enough for most people. The speed is about 100 megabit, which is crazy fast. You could watch a YouTube video 5 times over inside that 100 megabit limit. And one other project that I just started to work on this week is having the ability to stream the G3X data out to the internet to a server, meaning people watching maybe your YouTube feed on the internet could see all of the data going through or being logged to your SD card. Everything that you basically is displayed on the screen, you're going to be able to stream that to a server, and you're going to be able to present that as an overlay on your YouTube feed, or just record it somewhere.
Check
So I think it can be a really good safety enhancing device, but it can also be something where, people should be flying and instead they're watching YouTube videos. So it's a double-edged sword. So until next time.